Hey, it's Becky. Today I'll go over the process I used to create an automated cat food bowl for my elderly cat Chaz, using a Wi-Fi board, micro servo motor, and some 3D printed parts. Let's get started. See, Chaz needs to eat breakfast before he can get his insulin, but I often forget to pick up his food dish before I go to bed, which means he eats overnight, spoils his appetite for breakfast, which throws off his insulin schedule. This dish uses a servo motor to close a lid over the food between the hours of midnight and 7:30 a.m. You can find a link to the parts I used as well as the step-by-step tutorial at the links in the description below. This cat feeder may not be secure enough for younger, more active cats. Chaz is old and frail, and he isn't inclined to try to pry the bowl open. There are products on the market that serve this function and work better in terms of keeping the cat out. Videos of these are hilarious and well worth the binge. The cat food bowl holder is based on R.D. Lai's design on Thingiverse. I made it bigger to accommodate my cat's bowl and also made it shorter since scaling it up had made it too tall. I added a holder for a micro servo motor, which is a component conveniently included in Tinkercad's parts library, and a couple holes for cables to route to the inside. I modeled a simple lid which is designed to attach to the horn of the micro servo. You can grab my design directly from Tinkercad to make your own changes, or download my STLs at the link in the description. I printed the parts on my Creality CR10S Pro printer with gold PLA filament. I used a small drill bit to increase the size of the holes on the servo horn, then used screws to attach the servo to the 3D printed lid. Then I installed the motor lid assembly into the motor-shaped cutout on the bowl holder 3D printed part. The circuit is controlled by a Node MCU ESP8266 Wi-Fi microcontroller. I used header pins on a perma proto board to make the micro servo motor easily detachable. The servo headers are connected to the Node MCU as follows: the yellow servo wire to Node MCU D1, red servo wire to power either 3 volts or VIN, and the black servo wire to ground. Plug the motor header into the microcontroller board's header pins and plug the circuit into the computer with a USB cable. The Arduino sketch joins your Wi-Fi network and uses network time protocol to fetch the current time, then opens or closes the lid according to a hard-coded schedule. Copy the code you can find at the link in the description, update your Wi-Fi credentials and UTC time offset, I'm in the Eastern time zone, and upload it to your Node MCU board using the Arduino IDE. To make this code, I basically did what I always do, which is mash up multiple sample codes to achieve the basic functions I'm looking for. I made a video about this technique that I'll link in a card and down below. Basically, I took the NTP example and mashed it up with the servo sweep example, in which I changed the range of motion of the servo to be smaller than the default. I still need to improve this code to remove servo jitter, and I'm wide open to your suggestions. I routed the wires to the inside of the bowl holder, plugged the cat feeder into an outlet using a USB AC adapter. The way this simple code is written, it is meant to be booted up in the open state and will only change its lid position at the time threshold specified in the Arduino sketch. Thanks for following along. I'm curious if you have any ideas to improve the design or modify it for a different purpose. Let me know what you're working on in the comments below. If you liked this video, please give it a thumbs up and subscribe with the bell to be notified of my future projects about technology, crafts, and my life here in New York City. See you next time.